In this second week, we'll start by building the foundations of a blockchain. Think of a blockchain as a chain of blocks where each block contains data, is cryptographically linked to the previous block, and is validated to ensure the integrity of the entire chain. By the end of this lesson, you'll understand the anatomy of a block, learn how to create a single block, and build a simple blockchain and validate its integrity. So we're going to write a Python program to simulate blockchain operations. Here's a step-by-step process of building your Python blockchain. So step one is to understand the components of a block. We went through this last week, so this will just be a quick overview. We know that a block contains, and you can see here, we have index, which identifies the block's position in the chain. Timestamp, when the block was created, the data, the content or transactions stored in the block, previous hash, which links the block to the preceding one, and a hash, which is a unique cryptographic identifier for the block itself. So we already understand the components of the block and what goes in it. Next, we can go to step two. Now, step two is creating a block class. And we'll use Python to create a class for our single block. Now, this class will store block attributes, the index, timestamp, data, previous hash, and it'll compute a hash using the hashlib library. So let's break down this code line by line in simple terms. Now, the first thing we're going to write in our code is import hashlib and import date time. Now, hashlib this is just Python's built-in library for hashing data. And we know that hashing is a way to take data and turn it into a unique fixed string, like a digital footprint. And this is essential for securing blockchain data. Our next import is import date time, and this just allows us to work with dates and times, which we'll use to record when a block is created. Going down to creating our class block, and this just defines a block, which is the basic building block of our blockchain. And a class, think of it as a blueprint that describes what each block will have and how it will behave. Now, inside our class, we're going to define some things, and this is called our constructor. And this method, it will automatically run whenever a new block is created. So it sets up the initial attributes, which is the data for this block. So as you can see, we're going to define these attributes: self, index, timestamp, data, and the previous hash. Okay, and we already know what these parameters are. We're just setting up that initial attribute. Now, after we set this initial attribute, we actually have to go in and set the attributes on what it is. So for our self.index, which is our index, it's just the block position in the chain. So when it calls, for example, the timestamp, we have self.timestamp equals timestamp. And that's just saying the block's creation time. And we're going to do each one of these in order from where we listed. Like I said, these lines store the value passed to our constructor, like our index and timestamps, so these attributes can operate in the block. Now at the bottom of here, we have self.hash equals self.calculate underscore hash, which is the current block hash. And this just calculates the block's unique digital footprint using that calculate underscore hash method. So the hash will change if any data in the block changes. Now we have to define this calculate underscore hash. Okay, now to calculate this, we're just saying that we're going to combine the block's attributes into a single string. So all these attributes, the index, the timestamp, the data, previous hash, we're going to change that into one single string with like a hexadecimal string, okay? And it's going to convert that string into those bytes. We're using SHA-256 hashing algorithm here, so you can kind of see what the hashing string will look like, which I said is hexadecimal. I believe it's 64 characters. And it is going to be this unique hash to represent this block's data, okay? And then lastly, we have the return here, which is return hash lib dot SHA-256. And it's just saying to send the hash back to where it is called, which is back in this block here, where we have our self.hash equals self.calculate. And it's saying, hey, call on this calculate, this self.calculate hash, call on to it. And then what we did, because we're coding, we're making everything operate how we want it to. So how is it going to calculate its own hash? By this piece of code here, by saying combine all the block's attributes into a single string. And once you get that single string, the string is going to be in a SHA-256 algorithm. That single string will then be called upon in this previous code block, which is the self.hash. Now, last in this block here, we have representing the block, which we're going to define to represent itself, right? The block, how the block will look when it's printed or displayed on your screen. So the format of the string will show the block's index, the block's hash, the previous hash, and the data, right? So the input will look like what we just put it in here in code, just in plain simple terms. So you can see return, and it tells you everything it needs to return. So for this piece of code right here, how it's going to work, what we created it to do is a new block will be created by providing this index here, this timestamp, this data, and this previous block's hash. Then the block will automatically calculate its unique hash using these contents. And then this PR method, it will make it basically easy to view this block's data to us humans instead of, the computer. So that's our first block, right? That's our first class. It's the class block. Remember, a class is just a blueprint on how we want our block to look and what we want our block to do, to behave. So this class is just telling us, we just basically said what we want our block to look like and how we want it to behave. That's it, okay? It's a blueprint. And if you went over Python, the basics, you'll know what a class is, you'll know what objects are, constructors, and all these other things. So now we created our block. Now we have to create our blockchain class. So we're going to do another class, but it's going to be a blockchain class. And the blockchain is the chain of blocks. So we made one block. Now we're going to do the chain of blocks. So in this class, it's going to initialize with that Genesis block. We know a Genesis block is the first block in the chain, and then it's going to add new blocks to the chain, and then just ensure that that chain is valid, okay? So let's break down this code snippet line by line. So we have class blockchain, which we're just defining the blockchain class. This will hold and manage a chain of blocks, okay? Now, this class provides methods to create, add, and validate the blocks in this blockchain, okay? Now we have our constructor, which is going to initialize our blockchain. So we have we're defining it, and then our constructor. And this right here just starts off with the empty list, which will fill in with that Genesis block information. Again, Genesis is the first block. As you can see, start with the first block. And you went through Python, but just to reiterate here, when you see the pound sign and you see it in green, that just means it's a comment. So it's not part of the code itself. It will not run. It's just for us as developers and others who are looking at our code to kind of understand it better. So we know here that this line represents start with the Genesis block. Okay. Now the blockchain is going to be represented in this list called chain, as we can see here. And it starts with one block and then created by calling the other blocks, which is self-create Genesis block. You see right here. Now, when we're creating the Genesis block, we have to define it. As you can see, we're going to define create Genesis block self. And this is the first block and it has default value, so it doesn't matter, okay? Now, we're going through some of these codes. You should probably see it already from the first class that we created, but it's just simple parameters. We have the block, and 0 is the index of the block because 0 is starting the block off, the first one, the Genesis. You see we have the start of the date time, which just records the current date of that timestamp. We see we keep referencing the Genesis block, which is the placeholder for that block's data. And we're just recalling the 0, which is the previous hash. There is no other block before this Genesis block. So that's why we keep recalling 0 for this, creating this Genesis block. And that's just this line of code right here. The next line of code is retrieving the latest block. So as you can see, define get latest block self. So this method just gets the most recent block in the blockchain. All right. So in Python, we have that -1, and that just refers to the last item in the list. So it's going to fetch the last block in the chain. As you can see, self chain -1. It's just going to get the latest block. That's all that means. Next, we're going to define adding a new block. Okay. So this method creates and adds a new block for our blockchain. And the steps is, as you can see here, it says the latest block equals self, which just retrieves the latest block to the chain to link it to the new block. And then it's going to go to the next stage, which is new block equals block. And that's just creating a new block with the same parameters, the index, which is the position, the timestamp, the current time, the data, and the previous hash. And then lastly is going to do the self.chain append, and it just adds the new block to the end of the blockchain. It's just appending, all right? Going down some more, we're gonna define, is the chain valid? So we're just validating this blockchain. And again, the method just checks whether the blockchain is still valid and just make sure that no data has been tampered with. So we have for 1 in range, and that's just loops through all blocks in the chain, starting with block 1. Remember, the Genesis block doesn't need validation. That's the first one. And then it's going to retrieve the current and previous blocks with that current block and previous block. It's going to check the block's hash. So that's where we have the if current underscore block dot hash. So that just, again, verifies the block's hash if it's correctly being calculated. Okay. Now, if this hash doesn't match, the block basically saying that it's been tampered with, so the chain is invalid. And then the next we have to check the link to the previous block. So we have here, if current block previous hash, just ensures that that previous hash of the current block matches the hash of the previous block. If not, the chain is broken and the blockchain is invalid. So these are just steps we're checking to make sure that this chain is valid. And then lastly, it's just going to return true or false, right? Return true if all blocks pass the checks. It just says the blockchain is valid, right? So in this piece of code right here, where we're defining is the chain valid, we're going through these checks and balances, okay? So we're going to make sure that we're going to loop through all the blocks in the chain. We're going to retrieve the current data and the previous block data. We're checking the hash, and if the hash is not what it's supposed to be, it will not return true. It will return false. But if everything looks good, all the hashes match from the previous block, then it will return true. All right, that's all we're saying in this code. Is this chain valid or not? And that's it for this piece, for this class. So just in summary, the Genesis block is where that blockchain starts. This is what all the default values, and then it's going to add new blocks and link it together using the hashing algorithm. And then lastly, we're just ensuring that no data has been changed and the blocks are correctly linked with that validation. Okay, so we have our class block. We said, hey, this is what our block will look like and how it will behave. We have our class blockchain. This is what our blockchain will look like, and this is how it will behave. Now, let's put everything together and create the simple blockchain where we're adding the blocks, printing the chain, and checking if it's valid. So we have this snippet here where we have our create our blockchain instance, which it will create, as you can see, my blockchain. Then add new blocks to the chain. Then add new blocks to the chain. As you can see, the first block, second block, third block, and then it will print the blockchain. So print to us what the blockchain, what the data is. Make sure that it also prints the validation. Is this blockchain valid? And then it will try to tamper with the blockchain. We can tamper with it and change some data and see that, hey, is anything valid after tampering? Now, to run this code, all you have to do is save it. So I am using Visual Studio Code. You can use any IED that is good for you, even if you go all the way down to OneNote, excuse me, not OneNote, but Notepad or Notepad++. Those are really basic. I like Visual Studio Code because it actually shows up with different languages. Well, once you can copy and paste if you want, or if we went through this, you can actually type out every single line of code. But once you have that here and it looks identical as what I have, I want you to go ahead and save this file. And when you save this file, make sure you save it at the end has a .py, so it can be saved as a Python file. And when we call upon it, it will run Python program. So name it whatever you want. As you can see here, I named it my first blockchain.py. So when you also save it, make sure you save it in the correct location. So if you saved it on your desktop, you saved it in your folder, in your downloads, in your documents folder, wherever it is, make sure that you understand where you're saving this Python file. Okay. Now we're going to go to our command prompt. You should have Python already installed. If not, it's easy to check. You'll just go to your command prompt, your terminal on your computer, and you will run py. Okay, py, enter, or sometimes you might have to put Python, but press enter and it should display the version of Python. If it does, then you have Python installed. If it does not, go ahead to this website here, python.org/downloads, and download and install Python to your computer. Okay, so now you are in your terminal. Go ahead and navigate to your file. So you can do something like list to list the current directory and or what's in this directory. And I see that this folder, blockchain folder, is where my file is saved. So I'm going to say CD, which is change directory. Excuse me, CD, which is change directory. I'm going to say blockchain. Now I'm in my blockchain folder where I saved my file, my code. So let's go ahead and do py and run it. Well, let me show you. You can do list. And as you can see, here's my first blockchain. You can see that's my folder. I'm going to do py, and then call my folder name, my file name, excuse me, .py, make sure you do that. And we're just going to press enter. And as you can see here, we have, when I say enter, it's going to run, it's going to print. We know in Python, you say print, that's what's going to be displayed in the terminal. So the code did some things. And as you can see in our blockchain, it's showing that we have our block 0, our block 1, our block 2, our block 3. It even has the hash. As you can see in our block 2, it has the previous hash for block 1. Okay, in our block 1, it has the previous hash for our block 0. What is our block 0? The Genesis block. Okay, so all these blocks we have are in the blockchain, and then it's basically just determined whether the blockchain is valid before tampering, and then the results after tampering shows, and as you can see, is the blockchain valid? True, because we did not tamper with it. Okay, is the blockchain valid after tampering? If we did some tampering, it would be false. Okay, so what you can do for your coding assignment is change some of the data in the block and kind of observe how it invalidates the chain. You can even add more blocks with different data to see how that will display as well. Some other things you can do to get more understanding of this coding task is to include a Merkle root for transactions. And like I said, add a simple validation function to check if these transactions exist in a block. I want you to write a essay explaining the role of cryptographic hashing in ensuring blockchain immutability and how the chain structure detects tampering. In week 3, we'll dive deeper into cryptographic foundations for blockchain security. We'll implement digital signatures to authenticate transactions, and we'll learn how Merkle trees enhance efficiency and data integrity.